Assalamualaikum and good evening to Puan FAIZAH. My name is IRFAN Daniel bin HAZIRAH, and for today our group will present to you about simple gear trend or spur gear. So for the first slide, that is the contents for our presentation today. That will include our introduction, gear trend type and gear terminology, design and calculation, finding result, and lastly the conclusion. Let's start off with the introduction. Gear has been an important mechanical component for ages, like we all know, and they were used by earlier ancient civilizations to move machines, for example, for doing irrigation, crop processing, and construction. The Industrial Revolution that we all know increased the use of gears in machines for mass production and for transportation. And the example for parallel axis gears are such as the spur gears and helical gears. So at the right side is the image example for spur gear model. Next, move on to the next slide. The gear type. So the spur gears are the most easily visualized common gears that transmit motion between two parallel shafts. And so because of their shape, they are classified as a type of cylindrical gears. Since the tooth surfaces of the gears are parallel to the axis of the mounted shafts, there is no thrust force generated in the axial directions. Also, because of the ease of production, these gears can be made to a high degree of precision. On the other hand, the spur gears have a disadvantages in that they easily make noise. Yeah. Generally speaking, when two spur gears are in mesh, the gear with more teeth is called the gear, and the one with the smaller number of teeth is called the pinion. So here is the gear terminology, like the face width, the addendum circle, the pitch circle, the fillet radius, the clearance, and the right side is the same but with a different image. So that is our simulation video for this assignment, and our spur gear for this assignment that is made from cast iron. And yeah, that is the rolling video for our gears. So for the next slide, I will be passing on to Nur Fatin Hazirah. Thank you so much.
Thank you for my partner, Irfan Daniel. Before I move to the next slide, I will explain the design a little more. The design I designed by the Katia, explanation also by the Katia. Design, the outside diameter is 130 millimeter. The internal diameter is 100 and the pit diameter is 110 millimeter. The number of T is 70. Bond as both here is the same. The next slide, we will show you the formula we use for the assignment. We use the gear ratio and equal the number of T1 per the number of T2. Next, we use the force. The force equal mass multiplied with the acceleration. And next is angular speed. Omega works gear ratio multiplied with 2 pi per 60 seconds. Next, the torque. We will calculate the torque. Torque equal the force multiplied with radius. The last, we will calculate the gear efficiency. Like torque 2 per torque 1 multiplied with the gear ratio. Next, we will talk about the application of the spoke gear train. There are many applications that use spoke gear train because spoke gear train have the simple gear and the straightforward gear and not very difficult gear. Can apply in many things. For example, the first one is employer machine. Employer machine commonly is have at the factory. Second one is car transmission. So many cars have a spoke gear train. The next one is instead of the milling machine, they use the spoke gear train. The next one is RC car, is a stock car, also use the spoke gear. And the last one is the roller road. Roller road also use the spoke gear train. Next, finding result. From what we get, the first gear driver, like the last year saying, the design outside diameter is 150 millimeter, internal diameter is 100 millimeter, pit diameter is 110 millimeter, the number of T is 17. The next one is second gear driver. Outside diameter is 130 millimeter. Internal diameter, so here F is wrong. The actually is also 100. The pit diameter is 110 millimeter and number of the T is 17. That is the force. Before that, I missed the ratio. The ratio is the same because the bone of the gear spoke is the I designed the same diameter and the same number of the T. So the ratio of gear is 1. Both the gear is also the same. So both with the multiple weight expression. The mass is 0.01 meter multiple with 0.5 meter per second. So the answer is 0.01. The next one, calculate the speed. Omega. Omega equal gear ratio with 25 per 16. The gear ratio 1 multiplied with 25 per 6 seconds. The answer is 0.105 radian per second. The next one is dot. Task 1 and task 2 is the same. So, we calculate force multiplied with radius 0.01 Newton multiplied with 0.11 meter. So the answer is 0.0011 meter. The next one, we will calculate the gear efficiency for the first gear. The top 2 got 1 multiplied with the gear ratio. So 0.0011 meter per 0.0011 meter multiplied with 1. The answer is 4. And next, we will calculate the gear efficiency for the second gear. We take on the first one with the heart of the first gear. So the answer is 1 per 2. The answer is 0.5. The last one, we calculate the gear power. Power equal to multiple V of the 0.0011 Newton meter multiplied with 0.105 radians per second. For the answer is 0.0001155 watts. That's all the calculation for this assignment. The conclusion for the assignment is the performance of the project is determined by design, construction and materials. So, gear train are one of the most popular type of the gear train and are used in an endless number of applications. For the simple tool to the complex industrial machinery. Last one is good gear have a simple track to design that can be configured and shaped to fit the needs of any application. That's all for me.